Hello. Today's video has to do with how we graph motion and how we can interpret the speed of something's motion by looking at a graph. So far in this unit, we have talked about speed, average speed, the difference between speed and velocity, and if you are in challenge class, you've also learned about acceleration and how to calculate acceleration. Let's look at this graph here. This graph is called a distance versus time graph, or a distance time graph. This is the type of graph that would show the motion of an object. Anytime that you use this type of graph, time is always on the x-axis and distance is always on the y-axis. There are three things you can find out when you look at one of these types of graphs. You can figure out how far an object's moved, how long it was in motion, and from those two pieces of information, you can figure out the speed of the object. How far has this object traveled? Well, you can look at the distance on the y-axis, and you can see it started at 0 and went to 50 meters, so it traveled 50 meters. How long has the object been in motion? Well, looking at the x-axis, it's been in motion for 5 minutes. How do we calculate its speed? One way is to calculate the slope of the line. Rico says, I remember learning about slope in math class. I wonder if Mrs. Cox is talking about the same slope. Yes, Rico, I am. Math and science are very closely linked. In fact, math is considered the language of science. Let's review how to calculate the slope of a line. The formula for slope is rise over run, or rise divided by run. Now, what do we mean by rise? We mean how far did it go up on the y-axis. That's the rise. And in this case, it would be the distance traveled. And the run is how far did it go on the x-axis. And so the run in this type of graph is the time that it took. We're going to calculate the slope of this line. And in order to do that, you have to choose any 2 points on the line, but you need to make sure that it's right where the grid crosses and you have this little T. Okay, I could calculate slope using a point like this, but it would be much more difficult and it wouldn't be nearly as exact. All right, you see my 2 points that I've chosen. Here's a point here and here's a point here. And we said slope is rise over run. So we have the rise is here. You need to choose the rise for the 2 points that you have chosen on the graph. So going with the 2 points that I have here, how far did it go up? It went from 20 to 40, and so it went up 20 meters because 40 minus 20 is 20. The run is it started at 2 minutes and it went to 4 minutes, and so 4 minutes minus 2 minutes is 2 minutes. So we had only a 2-minute lapse of time here. And then if you go up to the top, we have our rise over run formula. So we have 20 meters divided by 2 minutes, which is 10 meters per minute. That's how fast this object was going. So every minute, the object covered 10 meters. This is also the same as using our speed formula. Speed equals distance divided by time. Let's look at our distance here. So our distance that it traveled was 50 meters. If you go over here, you can see that's 50 meters. And then if you go down here, you can see that it did that in 5 minutes of time. And so we take 50 meters divided by 5 minutes, which is 10 meters per minute. Notice, here's the speed using the speed formula. And then as I go back to using the slope, look, it's the same speed. It doesn't matter which way you calculate, rise over run or distance divided by time. Makes no difference. You're going to end up with the same speed. In general, what does the steepness of the slope on this type of graph tell you about the object's speed? Well, the steeper the slope of the line, the faster the object is going. So you can see we have 3 different slopes of the lines. We have a very steep slope here, which tells us that the object is going fairly quickly, because you can see it goes a far distance. It goes maybe 45 meters in just a little over a minute. So a little over 40 meters per minute. Now here we have a slope of 0. A horizontal line tells us something in particular on this type of graph. All right, so let's look at it. So between this time, between 2 minutes and 4 minutes, I know it extends farther, but between 2 minutes and 4 minutes, it has traveled how far? It has traveled no distance, right? Because it started right here at about 45 meters, and it is still at about 45 meters. So it went nowhere during this time. What does that tell us about its speed? Its speed is 0. That means it is not in motion, or it's staying still, not moving, however you want to say that. So a horizontal line on a distance versus time graph means the object is not in motion during that part of the graph. Now here, let's figure out what kind of slope do we have here. Well, we have a more shallow slope, or a less steep slope here, which means that this object is traveling at a slower speed than here. Because look here, we've got from 5 till almost 8 minutes, maybe 2.5 minutes. It only travels about 15 meters. So in that amount of time, it doesn't travel very far at all. So here we have a shallow slope, which tells us it is a slower speed than a steep slope, which tells us it's a faster speed. And remember that a horizontal line tells us that the object's not in motion during that time period. Let us look at this one too. I want you to look at from 0 to about 2.5 minutes. And you can see that the object is in motion, and it has kind of a medium slope. Not real steep, not real shallow. So it's traveling, we could say, at a medium speed. Then from 2.5 minutes to a little over 3 minutes, we have a very steep slope, and we could describe that as a fast speed. And then look at this other part from a little over 3 minutes here. Looking from here to here, we notice something different. We notice that the line is no longer going up here, it's going down. I want you to pause this video, and I want you to try to see if you can figure out what that means. So look at the distance here and the distance here, and look at the time here and the time here, and see if you can come up with a theory about what's going on. Okay, go ahead and pause me, and only turn this back on once you have a possible theory. Let's look at this. You can see that the object has already traveled about 45 meters from where it started here. Then you can see here that if we go over here, it's at about 25 meters. So you can see that it went from here to here, which means it started going back toward where it had begun its journey. And it didn't go all the way back. This line didn't go all the way down to 0 here. It started coming back toward where it started from, which we're going to call its reference point, or its origin. And what kind of speed do we have here? We have a medium speed happening there. Let's look at this one. Sometimes distance versus time graphs are not numbered, and they just show us a general distance and a general time. Look at this. We have two different objects in motion here. We have the bottom line, which you can see starts at 0 distance and 0 time, and then goes at about maybe a medium speed until it stops here. So you can see it stops at this time here, and it stops at this distance here. Now the one above it, what does this mean when it starts here? Well, that means that it didn't start at the same place that this started. It tells you that it started a little distance away from where the other one started. And when it started moving, it moved to here. And you can see that this top line has only been going for a short period of time, but it's gone a pretty far distance, and it has a steep slope. So that tells you that it is moving more quickly than the other object. Please go back and add some graph examples to your notes if you did not do that yet. And make sure you add a summary to your Cornell notes. You may need to watch this video again if you're unclear about any of the concepts that I talked about. You need to get in the habit of doing this. You need to get in the habit of going back and re-watching videos if you need to. All right, see you later. Bye.